All right, so we've talked about ionic compounds. Now we have to talk about ionic compounds that use polyatomic ions. So we'll learn what that is in a moment, but we need to make sure that we're comfortable with things. We need to make sure that we're comfortable with naming ionic compounds with a fixed charge and those transition metals that have a variable charge and how we write the names for things. So with ionic compounds with a fixed one, we just write the name of the cation, write the name of the anion. Done, easy. Then with the transition charges, we write the name of the cation. We put that charge in Roman numerals to let people know what it is. And then we write the name of the cation, again with an IDE ending. So what's a polyatomic ion? Well, a polyatomic ion is an ion with two or more atoms grouped together. It has a charge. Now, the charge is going to come from a list. So we have a list that we're going to be using to figure out what the charges are. So this is an example. They're in alphabetical order, so it's kind of easy to find. We can look down one side or the other. And we can figure it out. So some examples are hydroxide, OH negative, iodate, which is IO3 negative, nitrite, NO2 negative, or carbonate. So even carbonate can have a -2, right? So these end typically in eights or ites, with the exception of things like hydroxide. Now there's no element called hydrox. So it's hydrogen and oxygen. So there's two elements kind of squished in the word. So we have to kind of be detectives again and find not only what the charges are when we have a transition metal, but also really look and see if we have a common polyatomic ion. Okay. So we're going to follow the same rules. Only this time, instead of writing the metal's name, we're going to write the name of the polyatomic ion after. So we fix charge ionic compounds, we write the metal's name, then we write the name of the polyatomic ion. For transition metals, we do the same thing again. We write the metal's name, we give that charge in Roman numerals, and then we write the name of the polyatomic ion at the end. So let's take a quick peek at this. So we have potassium cyanide, calcium chromate, magnesium chlorite. Then we also have NaNO3, we have BaClO, we got two of those ClOs, and we got SrPO4. Let's start just with a nice easy one here, and let's look at sodium and this weird combination of stuff after the sodium. So we're going to break this apart real quick, and we look at sodium. I look over, it's on my group 1, so it has a +1 charge. Then I look over at my NO3. Now you'll notice it's not in parentheses like this one. It's by itself, so the whole NO3 stays together. And the only way that this could be a proper ionic compound with a neutral charge is if it also has a negative charge as a group. And I can check this. I can go over to my list, and I can look. Do I have an NO3 with a negative charge? And I do. It's called nitrate. So this is nitrate. And over here, we have sodium. Because they're fixed charges, I don't need Roman numerals. I'm done with naming it. So let's look at this one over here. So let's look at BaClO, and we have two of these things. So we got Ba, we look over, it's group 2, so it's a 2+ charge. Then we have ClO, and we have two of those. So what this is telling us is that there's two of these things, and we have Ba, right? Sorry about that. That should be a +2 down here. And I only have one of those. So if I have two of these, we can figure this out, right? It should be a -1 charge, +2 over here, -2 over here. So I can look. Do I have a ClO negative? Oh, ClO negative, hypochlorite. So this should be barium, hypochlorite. So same thing, just put in the name of the metal, put in the name of this now polyatomic ion there. So let's look at this one over here. We got strontium. Strontium is one of those 2 plusers on the other side. And this should actually have a 2 on there. Sorry about that, everybody. And this should be PO4. We're not quite sure yet. I know that I have 3 of these strontiums with a +2. It should equal whatever this is, right? So I can look again. Now, I don't actually even have to look, right? I know I have 2 of these with the charges. And I'm just going to look over here. I'm going to look for PO4. Is there only one PO4, which there is? Is there any other one? No. Then it's that 3 minus. So it has a 3 minus charge. It balanced out. It's fine, right? Nothing weird. I don't have to identify anything else. And then more or less, this is for practice at this point, but it's strontium. And then that other part, so I looked over that PO4 3 minus, it's phosphate. So it's strontium phosphate. Now what about up here? So let's go backwards. I have potassium and cyanide. So I know I have potassium. Potassium has a +1. And then I have cyanide. So cyanide, Cn minus. And so I got a +1. I got a -1 over here. They're nice and balanced already, so I can just put them together. KCN. All right, now let's look at calcium chromate. I got calcium. That has a 2+ charge on it. We have chromate, so let's see if we can find chromate. I'll look in the C's. CrO4. And it has a 2- charge on it. Great, so I look at it. Oh, good, it's balanced again. So it's CaCrO4. Now let's look at magnesium chlorite. So magnesium, again, this is on my group 2, so magnesium. We got a +2 charge there. And we got chlorite, so I look at chlorite. It is a ClO2-. Okay, so I have a +2 charge here. It has to equal this -1 charge for this whole group. So I have look at that. So I got a 2, and then I have to add another one over here. So 2 to balance out. So Mg, we didn't add a number out there, so it stays Mg. Now, to make 2 of these, I have to put them in those parentheses, ClO, and this is going to be 2 inside, but because I have another one, I have to have that 2 on the outside as well to say I have 2 of these chlorites. Now let's look at those examples with the transition metals. So same kind of rules, right? So we have nickel with this iodine and O3 on the side. So we need to figure out what the charge is on nickel. So we got nickel. We know it's got to be positive, right? It has to be the positive thing. I know I only have 1 of them, so I'm just solving for whatever's in that bubble. And then I look up IO3. So I look over on my list. And IO3 right there. So IO3 negative. So it's so that ends up being IO3 with a negative charge. So it's -1. So all right. So it has to balance each other, right? So if there's only 1 of each of these things, and I have a -1 here, I also have to have a +1 in this group. So we have nickel, 1, and it's iodate. Let me just double check. I'm looking over at my list. Iodate. Perfect. So now let's look at the next one. We got CO. So we don't know what it is. We know that there's 1 in there. And we equals, and I look up cyanide on my list. It's right there, Cn negative. So it's Cn negative for each one of those. I have 2, it's in parentheses, and I see that subscript. I got to bring that whole thing down there. So whatever this is, this one item has to equal the same as -2, so it's got to be +2. So it's cobalt. 2 cyanide. Perfect. Now let's look at this one over here. So we have chromium. And then we have CO3 here. So we're going to look through here. We got a CO3. CO3 2 minus. It's carbonate. So we got CO3. And I said it was 2 minus. Just double checking on my list, right? Carbonate. Yep, 2 minus. And I have 3 of those. So let's go here. Let's go. I have 3 of those at 2 minus. My chromium here, I have 2 of those, and I don't know what the inside is, but it has to equal 6. So 2 times what equals 6? It's 3. So plus 3. So we have chromium 3 carbonate. Great. Now let's look at the other side. So we have iron 2 chlorate. So we got over here iron 2, right? So I'm gonna look at what this is. So iron 2, that means that positive charge there, right? It has to be Fe 2 plus at least, right? And then I look over at chlorate. I look at my list. That's ClO 3 minus. So I use this to just look and see chlorate, ClO 3 minus. Now I have to get them to balance. So I have a 2 plus. It's got to equal a minus 1 for this group. I'm going to need 2 of these things, right? So let's balance it out. So it's got to be Fe. Fe is fine. I didn't put anything out front. And then I got this ClO3, but I did have an extra one, so I got to put it in those parentheses to say I have more than one of those groups. Let's go copper 1, right? So I got Cu. I know it's a plus 1 because of that. I look up oxalate. So oxalate on my list over here. I look through. Oh, oxalate's right here. So I got C2O4 2 minus. So that's a 2 minus. I got to balance out those charges, right? This is my plus 1 over here. It's got to equal the same. I look. This is what I need to balance out, right? So it's Cu2, C2O4. All right, last one we'll do together. Okay, so I got nickel. I see that too, so I know it's a plus 2 charge. I got phosphate, so I use my list to find phosphate. Phosphate's right here. It's PO4 3 minus. Okay, so I have a plus 2. I have a minus 3. I got to get them to equal each other. Lowest common denominator is 6, so how do I make them both 6? Right, there we go. So I get my Ni3. And then we're going to put this whole thing in parentheses because it's a polyatomic, right? PO4. And I needed 2 of them, so I put that little 2 on the outside. So the rules really haven't changed much. The only thing that we're doing is we're adding groups. So we have to add in parentheses when we're doing more than one thing in the formula. And then the other part is we just have to find what we're looking for on this list to find the charges, but to also find what we need. So if it has a fixed charge, we can just use the names. If it has a transition metal in there, we just have to discover the charge. And then we have to get those charges to balance to make a nice neutral compound. All right, that should be everything that you guys need. Have a good day. Bye.